shapes of organic compounds and structural representation of organic compounds. We already know that tetravalent nature of carbon and the formation of covalent bonds by it are explained in terms of its electronic configuration and the hybridization of s and p orbitals. It may be recalled that formation and the shapes of molecules of the hydrocarbon family can be understood by the usage of sp3, sp2 and sp hybrid orbitals by carbon atoms in the respective molecules. The different hybrid orbitals such as sp, sp2, sp3 possess different chemical and physical properties. Hybridization is the governing factor which decides the properties like electronegativity, bond length, enthalpy, and strength of the compound. When the two atoms overlap due to the sideways overlap of their p orbitals, the covalent bond is called as pi bond. In a pi bond, the electron density is concentrated in the region perpendicular to the bond axis. Characteristics of the pi-p bonds. The pi bonds are weak because the orbital overlap is partial. For a complete sideways overlap, the p orbitals should be parallel to each other. The electrons in the pi-p bond are placed above and below the plane of the bonding atoms, and so they are more exposed. We use Lewis structure to represent the two-electron covalent bond structure of hydrocarbons. A single dash represents a single bond, double dash is used for double bond, and a triple dash represents triple bond. The organic chemists are also using only lines to represent the structures. In this bond line structural representation of organic compounds, carbon and hydrogen atoms are not shown, and the lines representing carbon-carbon bonds are drawn in a zigzag fashion. Molecules are three-dimensional, 3D structures, so it is always more accurate to describe them in 3D. Representations of organic molecules in 2D, such as fully displayed formulae, are often used for speed and simplicity. The benefits of drawing include the possibility of including information about bond angles and therefore the shapes of molecules, and isomers including stereoisomers. Symbols commonly used to represent the three-dimensional, often called simply 3D arrangement of atoms in organic molecules include normal lines or normal bonds are used to represent covalent bonds lying in the plane of the drawing surface, that is, paper, textbook, or screen if viewed electronically. Dashed bonds are used to represent bonds that project backward behind the drawing plane. Wedged bonds are used to represent bonds that project outward or forward in front of the drawing plane.